So now we've got some similar triangles, and we know that in similar triangles, we can create sides that are proportional. So some cool things happen when we have some parallels drawn and things like that. So the first thing is if side OE is parallel to side NL, are these two triangles similar? Is triangle MOE and MNL similar to each other? Well, let's think about it. I know parallel lines make alternate interior angles. So I know that these two angles are corresponding angles, and they're congruent. I also know that these two angles are corresponding angles. They're congruent. I also know that angle M is a shared angle. So all three angles of the triangles are congruent. So that means our triangles have to be similar. Yes, they are. So that means if my triangles are similar, I can determine the length of segment LE, the one that I've called the variable y. So let's play with that a little bit and see what we can do. If my triangles are similar, and I'm going to, okay, strategy number one, redraw your triangles. I think that's a great strategy. Students who redraw triangles get questions like this right all the time. Okay, so this length then is 36 plus 48. This is my bigger triangle, and that comes out to be 84. And the bottom is going to be y plus 60. So if I can write a proportion now, maybe I'll say 48 is to 60 as 84 is to y plus 60. So if we're going to solve that, we can probably do our distributive property, combine some like terms. I'm sure you could do the arithmetic. You should get that y is equal to 45. Pretty good. So let's try some other ones. So I have another parallel line drawn on the left. I notice if I can separate my triangles, I got this one here. So maybe I'll say like 8 is to 12. And maybe I'll do a bigger one here in red. So now this whole side is 24. So 8 goes with the 24. And on the other side, I have 12 plus x. Again, if you want to solve that equation, I think we're going to get that x is equal to 24. Interesting. You noticing some things? How about over here? I have another pair of similar triangles, so maybe I'll go like 20 is to 25. I'll take this big green triangle here, and I'll make, let's see, 25 plus 45 is 80. Nope, 70. So let's see. Oh, I got to go the right way, though. If I'm doing 20 over 25, I have to do 20 plus x over 70. And when I solve this equation, I get that x equals 36. So when you take a look and you start noticing some of these answers, do you notice that not only, for example, like over here with this whole length being 36, yeah, 8 times 3 is 24. There's a dilation of 3 going on. But also 8 times 2 is 16. And 12 times 2 is 24. Pretty neat stuff. And if you take a look at 25, what do you multiply 25 to get to 45? I don't know. But if you think about the ratio of 25 to 45, if you do that in your calculator and compare it with 20 over 36, or even if you just reduce those, okay, 25 and 45 I can divide by 5 and I get 5 over 9. 20 and 36, if I divide them by 4, I get 5 over 9. So here's a really cool thing. It's worthy of a conjecture. Conjecture number 98. If a line is parallel to one side of a triangle and it passes through the other two, it divides the other two sides proportionally. Here's what that means. I'm going to draw you a picture. If I have a line that passes through a side of a triangle, what that means, and let's just clone that real quick and slide it over here. What it means is that if I call that side A and that side B, and that side C and that side D, it means that the fraction A over B is equal to C over D. And conversely, if a line cuts two sides of a triangle proportionally, then that line has to be parallel to the third side. So in between here, I'm going to put like a double arrow, meaning that if you're given a line parallel to a side of a triangle, it makes a proportion out of the other two sides. But if you know that there's a proportion that is true, it means that that line is parallel. So it's like a two-way thing. So let's play a little bit with this. And I know you're saying, wait, we didn't do it for 2, but it doesn't matter how many parallel lines cut the triangle. So if I just take a look and I want to find the value of P, okay, P is cut by this line here. I know 3 over 4 equals 4 over P. That's one of my equations I can write. And when I solve that, 4 times 4 is 16. 16 divided by 3, 16 over 3, let's call it that. That's okay. And likewise, if I look to find Q, I can go 2 is to 3 as Q is to 4. 2 times 4 is 8. Divided by 3 is 8 over 3. So those are my two answers. P is 16 over 3. Q is 8 over 3. Doesn't matter how many lines divide it. Just write proportions. So in this diagram below, E and B are points so that EB is parallel to DC. All right. If I got parallels, I know it divides it proportionally. Cool, let's label some sides. AE is 3, ED is 6, DC is 15. How big is EB? I'm going to call that X. So check it out. If you write 3 over 6 equals X over 15, you're wrong. You're wrong if you do that. Separate your triangles and take a look at it. Okay, that's no good. If I separate my two triangles, call that 3, call that X. Here's my big triangle. Move all that stuff down. Woo, there we go. Here's my big triangle. This side is 15. This whole side is 9. It's 3 plus 6. Separate your triangles. It's so helpful. So now if we do like 3 over 9 equals X over 15, we can solve this and we get X equals 5. So wait, because I'm going to show you I'm going to put one of those on your test really soon. Don't make that mistake. Separate your triangles. Take a look at this last diagram. You think these two triangles are similar? If you know that angle B is congruent to angle CFE? Well, notice that here's triangle CFE. We'll draw a triangle CFE in green. And we'll draw a triangle ABC in red. Do you see that they also share angle C? So that's going to also mean that the third angles have to be congruent. These triangles are similar. Yes, they are. They have congruent angles. So I'm going to kind of redraw those triangles in a minute. So I'm going to take my top one, my green triangle, and it might look something like this, where this is C and that's F, and this is E. And I'm going to turn my big triangle to match up with it. So it's going to look something like that, the big one. I'm going to stick C in the same spot. And this time B is going to be up top, and A is going to be over here. So what I know is that triangle CFE is similar, I got to name it the right way, triangle CBA. Match up those corresponding angles. So why did I make you do all that? Because here's that diagram again. Suppose these measures are true. Can we find AF? Pause if you'd like. Okay, I'm going to redraw my triangles. Again, when I redraw my triangles, I feel good. That's C, that's E, that's F. And again, the other triangle, C is over there. We're going to put A down here. We're going to put B up top. So let's label some sides now. CE is 18. CF is 12. Okay, I can write a proportion. I can say like 12 over 18. I know corresponding sides are equal. And I know that BE is 12. Oh, that's interesting. So BE is 12. And I know CE is 18. So that means that this whole side here, CB, is 30. So let me put a 30 up there. And I want to determine the length of AF. I don't know how big that piece is. But did I know that CF was 12? So I can do two different things here. I can either write this equation then. I can call that side x plus 12. And I can do this and solve for x. I might do something a little different though. What if I call this whole side y for a minute? Make my equation a little bit easier. Make it 30 over y. So now when I solve this equation, what I end up doing is oh, look at this. 12 over 18, isn't that 2/3? So if this is really 2/3, then this has got to be 2/3. So that means that if I divide the top by 2, I get 15, and then 15 times 3, so y is going to be 45. So if my whole length is 45, that's AC. AC has a length of 45, but I want AF. So that's 45 minus 12. And 45 minus 12 is 27. So the length of AF is 27. Hey, that's a tough problem. Could you imagine how hard it would be if you didn't separate the triangles? Hey, mamma mia.